Okay, so this video is to go back over the lid lab that we did about a week ago. And so that day we came in class and each person got about 7 lids that varied in size, some measuring tape, and the equations that we were going to be using on the lab were circumference is equal to 2 pi r. The slope of a line on a graph is equal to the change in y divided by the change in x. Now if you need that further defined, change in y is y2 minus y1, and change in x is x2 minus x1. Okay, so we measured with the measuring tape the circumference of each lid and the diameter of each lid. Okay, we measured the circumference and the diameter. Remember, the diameter is all the way across and circumference is all the way around. Okay. So then moving on, this girl measured her data that she needed to get, and then she made a graph, but it wasn't just any graph. I said you have to design a graph so that your slope will equal pi. Okay, so I gave you a specific task. Your slope has to equal pi. So at that point, she took this equation and she rearranged it for pi. So circumference is equal to 2 pi r, and down here in her work area we've got she took out 2r here and put in diameter in its place because diameter is twice the radius. So we end up with circumference is diameter times pi. So when we rearrange this for just pi, we divide both sides by diameter, and we end up, and I wrote it right here, we end up with pi is equal to circumference divided by diameter. So with this, she decided which variable to put on the y-axis and which variable to put on the x-axis. So I told her that I wanted the slope to equal pi. So pi is equal to circumference divided by diameter, but since pi is also the slope, it's equal to change in y divided by change in x. So when I get my change in the y-axis, I want to get circumference. When I get my change in the x-axis, I want it to be diameter. So she chose to put circumference on the y-axis and diameter on the x-axis. Zoom out just a little bit so we can see this better. She did a great job on her graph here. She went it by 2's for circumference, so it made it a nice long y-axis. She went it by 1's for diameter, plotted her points, and notice she did not connect the dots, but she made a best fit line. So a best fit line is kind of like the average line, and it runs right through the middle of all your points. Sometimes the points that you have plotted will be on the line. Sometimes you may not have any points actually on the line, but this is an average of all those points that you've plotted. Okay, so once she had her points plotted and she drew her best fit line, she had to calculate the slope of this line. And so when you stretch your graph out, it makes the line really nice because it gives you more points that you could pick to calculate the slope. Now, it does go through 0, 0, so that's 1 point she could have picked. But if you follow the line, this one crossed right here at a cross point, so it's easy to read on the y and easy to read on the x. And so she picked that point. There's another good point that she could have picked, and there's another good point, and there's another good point. So she had several choices, but she showed us the 2 that she picked, and then she drew little dotted lines over to the y-axis and the x-axis. So this was her y2 and this was her y1. This is her x2 and this is her x1. She labeled them, all very nicely done. So to calculate the slope, she did y2 minus y1 divided by x2 minus x1. Now to put this in your calculator all in one step, you would need to do parentheses open, 26 minus 10, parentheses closed, divided by, parentheses open, 8 minus 3, parentheses closed. Okay? And she ended up getting 3.2 for her slope. Now, there should have been centimeters here and centimeters here, and the units would have canceled, so literally just 3.2. Okay, pi is about 3.14. So to get her percent error, she got the difference in her accepted value and her experimental value. And then she divided that by 3.14 and then multiplied that answer by 100. Be sure you notice that we have absolute value signs here, so if you get a negative, just knock the negative off. So for the quiz we have coming up, you need to make sure you know the percent error equation, the slope equation, and also if I tell you, hey, here's an equation and I want you to make a graph so that the slope is equal to blank, whatever it is in the equation, you need to rearrange that equation for the variable that I want the slope to be equal to. And once it's rearranged, whatever is on top will go on the y-axis and whatever is on the bottom will go on the x-axis. Good luck on the quiz.